I recently thought of a way to generate random numbers on an esp32 offline. Let's see how well that worked out. Alright, so offline is debatable, but the idea is pretty simple. ESP32s have something called promiscuous mode, which allows you to intercept packets from the airwaves. What we'll do is we'll receive these packets, run a hashing function on them, and use that as our random number. CRC32 is one such hashing function. It's great because it's already included in the ESP library. The only question on my mind is how random will it really be? And to answer that, it's going to require some tooling. For this project, I want a database filled with numbers that I can access in a Jupyter notebook so I can run some distribution analysis on them. I went ahead and made such an API. It was pretty simple, and since we're using an ESP32 already, it's going to be very easy to connect and send this information into the database. But how exactly will I generate these random numbers? Two ideas come to mind. The first is a bit generator. Each packet will contribute a single bit of randomness to the overall number. I'm guessing this approach will be more resilient to duplicate packets. Contrast that with my other idea, which is to just store the whole CRC32 hash directly. Much faster, but if there are duplicate packets, you'll get duplicate numbers. Alright, let's implement both of these algorithms and find out which is better. After a brief coding session, I have everything set up, and I can already tell you the second algorithm is very fast. But let's go ahead and generate some random numbers so we can find out for sure which algorithm is better. Okay, it's been running for a few hours. On to the analysis. I've prepared a scatter plot and 2 histograms. Let's go ahead and see what it looks like.
Wow, I would not have guessed, but this bit generator performed terribly. At a glance, we can see these striations emerging, which tells me it's not very well distributed. I mean, if patterns are forming, that's a clear indicator it's pretty deterministic. It also has a lot of duplicate numbers. 13% of all numbers being generated is a lot of duplicates. Now let's check out the other data set. This one is much better. It still consists of around 10% duplicate values, but I have to imagine that's just part of networking protocols. It's overall better, and honestly, for a side project, I'd totally use this to seed a random number generator. For completion's sake, here's what it looks like with a true random distribution. I know there's got to be a better way to visualize this data, but intuitively, I think it's safe to say that neither of my random generators are remotely similar to an actual random distribution.
Still, I think it's a useful technique. But how might this method fall apart? Well, I'm glad you asked. There are 2 potential problems with this approach. The first is that you need to have computers online chatting away. Great in an apartment, probably not great in a Faraday cage. The other problem is that a bad actor could flood the airwaves with the same identical packet, making your random number rather deterministic. So don't use this for any cryptographic purposes. But in a pinch, I think it's a good technique if you want to generate a random light sequence or seed a pseudo-random number generator. I'll definitely be using this technique moving forward in my own projects because it's just so easy to implement. Anyway, thanks for watching. I hope you've enjoyed this video. Remember to like and subscribe for more content.